right, today we're going to talk about graphing functions, and then we're going to identify what the domain and the range is for that function. Keep in mind that the domain are the x values that define the function, and the range is the y values that define the function. So let's start with a function. We're going to graph today f of x equals x squared minus 3. So in order to graph this function, let's first make a function table. We'll have our inputs, our function, and our outputs. Okay, and then we're going to pick what we're going to use, what values we're going to use. So I'm going to pick -3, -2, -1, 0, 1, 2, 3. You always want to do some positive, some negative, and definitely 0. So -3, we're going to square them all, and then we're going to subtract 3. So -3 squared is 9, minus 3 gives you 6. -2 squared is 4, minus 3 gives you 1. -1 squared is 1, minus 3 gives you -2. 0 squared is 0, minus 3 gives you -3. And then 1 minus 3, back to -2. We're going to start seeing a repeating pattern since this is a quadratic function. 2 squared is 4, 4 minus 3 is 1. And by looking at this pattern here, we should know that this value is going to be 6, but just check. -3 squared is 9, minus 3 is 6. So there is our function, and now we have to graph it. These are going to be our ordered pairs here, x, y, x, y, and so on and so forth. So let's draw our graph. Now, just to be able to draw my graph accurately, my x values, according to this table, for right now, only have to go from -3 to +3. And if I look at my y values, I have to go, my lowest is -3 and my highest is 6. So that kind of gives me an idea of how I should make my graph. So I'm just going to sketch a graph right on the side here. Now we can start plotting our point. So we have -3, 6. So -3, 6 is right here. -2, 1 is over here. 0, -3. And then we have 1. Oops, I forgot to do -1. -2, 1. -2, 2, 1, and 3, 6. So there's our graph. Now I am going to connect the points to see the trend. Goes down and then back up again. And it's going to continue. So now let's look at our domain and our range. Again, the domain is your x value. So if I look at this, right now, my domains from my table go from -3 to +3, but according to my graph, since this is continuous, it's going to go on in all directions on the x-axis. I could plug in 4 into the function and get a range, and I could plug in 100 into the function and get a range. I could go to -100. Because I have so many values, I could plug in any value for my range, my domain. My domain is all real numbers. So domain is all reals, because I can plug in any x value I want and get an answer for my y value. So my domain is all real numbers. However, that's not true for my range. Your range are your y values. If I look at this, -4 is not contained on the graph. -6, -5. My graph does not go below this value here. This is considered your vertex or your minimum. It's a minimum here because it's the minimum value on the graph. It doesn't go anywhere lower than -3. And this is the point 0, -3 for this function. So it's not going to go below -3 on the y-axis. And again, we're talking about a range, so we're only concerned with the y-axis right now. It is at -3, but it's not going to go below -3. And if you notice, it goes to all these y values above -3. Where y is 2, I have a domain here and a domain here. When y is 5, I have a domain here and a domain here. So my range becomes an actual range of numbers. It's where y is greater than or equal to -3. So it's where your graph, the lowest point in your graph and everything higher for the range.